Hello, for this interactive advanced concept, I am making elephant toothpaste. So first I have this bottle here, which I added some hydrogen peroxide, and then I added some drops of dish soap, and then I added a couple of drops of green food coloring in here. And then in this cup, I have about a packet worth of just a pack of the yeast mixture, and then I added some hot water and mixed it around. And then I'm going to pour this into the bottle. So as you can see, it started to bubble and foam immediately, and then it started to overflow and is now rising out of the bottle and onto the plate here. So it's still coming out of the bottle and still making a green type of foam. Okay, so as you just saw from before, I made elephant toothpaste, and my ingredients for this experiment were hydrogen peroxide, warm water, yeast, soap, and food coloring. So like I said before, first I took the bottle and I added some of my hydrogen peroxide, and then I just added a couple of drops of dish soap, and then I added a couple of drops of green food coloring, and then I took another cup and I added hot water to a cup of yeast and mixed it around until it started to come together. And then I added the cup of hot water and yeast to my original cup of ingredients, and it immediately started to bubble and foam before I was even finished pouring, and just started to overflow out of the bottle. And the yeast and hot water caused the hydrogen peroxide, the dish soap, and food coloring to bubble and to foam, and eventually to come out of the bottle and all around the plate. And this is because the foam was green because I used the green food coloring, but I think that any color would have done the same, or if I could have maybe combined some drops of food coloring, it would have made a multicolor elephant toothpaste. But each tiny foam bubble is filled with oxygen. This is because the yeast actually removed the oxygen from the hydrogen peroxide immediately after it was combined. And the yeast acted as sort of a catalyst for this reaction, which caused it to create a lot of bubbles in a very short period of time. And the bottle also got a little bit warm after the mixture was created. And this is because the reaction was exothermic, and in an exothermic reaction, heat is being released. So therefore it created heat and the foam in the bubbles, and the bottle is a little bit warmer. So the foam or oxygen-filled bubbles are what remains of the hydrogen peroxide after it is broken down, like I said, and it's broken down into water, H2O, and oxygen, O2. And like I said, the yeast is what helped to release the oxygen molecules from the hydrogen peroxide solution. And a couple of factors that I think would have affected the magnitude of the foam formed and the amount of time it took to overflow is probably the percentage of hydrogen peroxide. So if I would have used a higher percentage, it would have probably created more elephant toothpaste, or caused the reaction to occur in less time if I if I used more yeast, it might have reacted more quickly and overflowed out of the bottle faster. But it was cool to see how quickly it took for the yeast to remove the oxygen from the hydrogen peroxide and just turn the entire mixture into bubbles and foam. And so as you can see here, it is still, it has stopped overflowing, but it is just still just sitting here on the plate, and it is like a green foamy mixture that was created. But this was a pretty interesting experiment that I did enjoy doing and making some elephant toothpaste.